discussing about system of linear equation solution using Gauss-Jordan elimination. On the previous video, I used Gaussian elimination to solve this for four equations for unknowns. Here, I'll be using Gauss-Jordan elimination. The idea of Gauss-Jordan elimination is when you have this kind of equation ax equals b in matrix form, you will transform that into that, okay, wherein your A matrix is now a diagonal matrix. Then you have the unknown variables x1, x2, x3, x4 equal to B prime, or the transformed B matrix. Okay. Okay, so similar to what we did on Gauss elimination, we have a C matrix here wherein we combine both the A and B matrix, right? So this is your A matrix while this is our B matrix. Okay, remember in SMAT I used augment command, no, to combine these two matrices. Okay, the first step is we will normalize the first row. Okay, when we say normalize, we will multiply by a certain number such that the first element of the first row will be 1. Okay, so in this case I wrote down the first row here, then multiply that by 1/4 to make this 4 1, right? So 1/4 multiplied to the first row, it will be transformed into this matrix. Okay, so 4/4 is 1, negative 2/4 is negative 0.5, 3/4 is 0.75, 6/4 is 1.5, and 12/4 is 3. Okay, now once you have that normalized matrix, row matrix, we will subtract that as to the next 3 rows, right? So like what we did in Gaussian elimination, no? So I wrote down, we will wrote down this normalized row matrix, this one, and then wrote down each row matrix here, okay, and then subtract them. Okay, so like here, one. So all the red row is the normalized matrix here. Okay, I forgot this to make this red. Okay, now similar to what we did with Gaussian elimination, find the multiplying factor in our normalized matrix, row matrix, so that when we subtract these two, this becomes 0. Okay, and what is that? In this case, the multiplying number is negative 6. In this case, the multiplying number is 1, while here the multiplying factor is negative 12. Okay, what do you notice? You notice that the multiplying factor is actually the first element of this matrix, right? This is 1, this is 1. Okay, right? So this is negative 6, this is negative 6, this is 1, this is 1. Okay, while here this is negative 12, this is negative 12. So with that, you will notice that in my SMAT code, this is my formula to get the multiplying factor. Okay. Okay, so once you have that multiplying factor established already, then subtract this two equation. Sorry, two matrix. So negative 6 minus negative 6 times 1, of course that will be 0. 7 minus negative 6 times negative 0.5, that will be 4. 6.5 minus negative 6 times 0.75, 2. Negative 6 minus negative 6 times 1.5, that's 3. Negative 6.5 minus negative 6 times 3 is 11.5. So you do the same process here, okay, here, and then therefore this three row matrix here is now transformed as this. Okay, 0, 4, 2, 3, 11.5, 0, 8, 7, 4, 13, and 0, 16, 6.5, 17, 53. Now we will now update our C matrix. Our C matrix will now be this. Okay, so we simply have to merge or insert all those transformed matrix. So here, this one is here. Okay, this one is this one is this. Okay, while this one is the normalized matrix here. Okay, so that will be I assign that as say C2. So just to show that our original C becomes transformed into C2. Okay, so that's the second stage. The next stage is we will normalize the second row. Earlier we normalized the first row. Now we will normalize the second row. Okay, and then repeat the same process. So to normalize that, so 0, 4, 2, 3, 11.5, this one. Again, we wanted this 4 to become 1. So what number will we multiply that row? It's 1/4, right? So 1/4 multiplied by 0 is 0. 1/4 multiplied by 4 is 1. 1/4 by 2 is 0.5. 1/4 by 3 is 0.75. Then 1/4 by 11.5 is 2.875. Okay, and then as we did earlier, I rewrite this normalized matrix here, the red one. Okay, and then rewrite the 3 rows over here. So 1, negative 0.5, the first row. The third row is 0, 8, 7, 4, 13, and the fourth row is 0, 16, 6.5, 17, 53, and then subtract them, right? Again, we will we will find the multiplying factor again as we did earlier. And what do you notice? The multiplying factor is simply the numbers here. If, since we wanted this one to be 0, so our multiplying factor is negative 0.5. Okay, we wanted this to be 0, our multiplying factor is 8 here. Okay, we wanted this to be 0, our multiplying factor is 16. Okay, we're just copying. Okay, so again, subtract this two row. So 1 minus negative 0.5 times 0 is simply 1, because any number multiplied to 0 is 0. Okay, negative 0.5 minus 0.5 times 1 is therefore 0. Okay, negative 0.75 minus negative 0.5 times 0.5 is negative 0.5. Okay, this will be 1.875, 4.4375. Okay, so of course this is 0. 8 minus 8 times 1 is 0. 7 minus 8 times 0.5 is 3. 4 minus 8 times 0.75 is negative 2. Then 13 minus 8 times 2.875 is negative 10. So repeat the same process here. Now our C2 will now be transformed into C3. Okay, we're just going to merge all this transformed uh, row matrix. So where is our normalize here? This is the normalized one, which is the second row. Of course, this is the second row, right? So this is the first row here. The second row, third row is here, while the fourth row is here. Okay. So earlier, our last normalized matrix is the second row, right? Now this time, our normalized matrix will be now the third row. Okay. And then we repeat the same process. What do you notice? There's a progression of the zeros coming out, right? So on the first stage, all zeros are on the first column. On the second stage, the second column are all zero, except the diagonal, of course, diagonal element. So in this third stage, our target is this will be zero, okay? Except this will be one, okay? Because we will normalize this third row, okay? So here, rewrite the third row: 0, 0, 3, -2, -10. Okay, so of course, to make this 1, we will multiply that by 1/3. So 0, 0, 1/3 times 3 is 1. 1/3 times -2 is -0.667. And then -10 over 3 is -3.333. Okay, so we now have the normalized matrix here. Then, as we did earlier, we will rewrite again the rows above. So this one is here, this one is here, this one is this. Okay, and then all the normalized matrix is here, is here, and then here. Okay, and then the multiplying factor, since we target this to be 0, we will copy this. Okay, so that is -0.5. We wanted the third element to be 0, we will copy this as the multiplying factor. Okay, the so on and so forth. Okay, so again, subtract this two equation. So 1 minus 0.5 times 0 is 1. 0 minus 0 is 0. -0.5 minus -0.5 times 1 is 0. Okay, 1.875 minus 0.5 times -0.667 is 1.5417. And then 4.4375 minus 0.5, -0.5 times -3.333 is 2.7708. Okay, so repeat the same process here. You now have another transformed matrix. So our C4, which is we have C3 earlier. Now the C3 now becomes C4. So let's just copy this first row here. This is I think this is the second row. This is the fourth row. And then the third row is the normalized matrix here. Okay. So we're done with the third row. So finally, we will normalize the fourth row. That's our last row matrix. Okay. So we will normalize this. And as you noticed earlier, our zeros are in the second column. Now, the zeros are in the third column. And then, by normalizing the fourth row, our 0 will now be on the fourth column. Okay. So normalize the fourth row. I'll rewrite first fourth row 0, 0, 0, 4, 2. Of course, to make this 1, multiply that by 1/4. So that becomes 0, 0, 0, 1, and 0.5. Because 2 over 4 is 0.5. And okay, so I'll rewrite that again. So the normalized matrix is this, normalized matrix is this, normalized matrix is this. Then copy the first row here. This is the first row, this is the second row, and then this is the third row. Okay. Since we wanted the fourth column to be 0, we will just copy this. So that's it. Fourth column is 0, copy this here. Fourth column is 0, copy this. That's it. Then perform the subtraction. Okay. So 1 minus 1.5417 by 0 is 1. Okay, 1.5417 minus 1.5417 by 1 is 0. 2.7708 minus 1.5417 by 0.5 is 2. And then combine all this row matrix. So again, this is our fourth row. So that's it. This is our first row. That's it. This is the second row. That's it. And then finally, this is the third row. That's it. Okay, so you now have the final answer already. As you notice, remember, the first row is x1, second row is x2, x3, x4. Okay, so by interpreting that, okay, we can simply rewrite that here as, if I rewrite that here, that is simply, so x1 plus 0 x2 plus 0 x3 plus 0 x4 equals 2. Okay, so since 0 is x1, x2 plus 0 x3 plus 0 x4 is equal to 4. So I think you now understand why I will not rewrite now x1 here and x2 here. So x3 so is equal to -3, while here x4 is equal to 0.5. So that's our answers. x3 is -3, x2 is 4, while x1 is 2. So in Gauss-Jordan elimination, we already got the value of the unknowns. Okay. Unlike in Gaussian elimination, we first get the x4 and then successively substitute that to find the other variable. Okay. So I have here the SMAT implementation of that thing here. Okay. This one. So it's just a 2-page SMAT code. So again, I will no longer reiterate the importance of this kind of spreadsheet or code, because remember, if you have, say, another 4 equation for unknown problem, simply change the coefficients here, the elements here, and the B matrix here, then you will right away get the final answer. Okay. So that's all for Gauss-Jordan elimination.